Hello all, my name is Chinmay Deshpande and today we are going to discuss solution of linear simultaneous equation by using Gauss elimination method.
Before that, we'll understood what is linear simultaneous equation. What is a linear equation? It is an equation in one or more variables where each term's degree is not more than 1. That means a variable x may appear but neither any higher power of x such as x square or x cube or nor any product of variable such as x into y may appear. In fact, any linear equation can be put in the form of c1x1 plus c2x2 plus up to cnxn equal to co or c0, where n is the number of variables. The variables are x1, x2 up to xn and c0, c1 up to cn are constants. Let us consider an example which contains unknown values of x and y. X plus y equal to 8 and x minus y equal to 2. So if we determine the values of x and y such that equation 1 and equation 2 holds true, then two equations are called as simultaneous equation as they are considered together.
Let's discuss steps to solve the problem. This is also a theory which is associated with it. While solving the problem of this method, follow the steps which are given below. Step number 1. Perform first partial pivoting. Now, suppose if you have a set of an equation, then on a set of an equation, you have to perform first partial pivoting. Now, what is partial pivoting? Always do a partial pivoting means arrange the equations in the following manner, having the highest value for all the diagonal elements. The numerically largest coefficient of x is selected from all the equations are pivot and the corresponding equation becomes the first equation. Next, the numerically largest coefficient of y is selected from all the remaining equations as a pivot and the corresponding equation becomes second equation. This process is repeated till an equation into a simple variable is obtained. Step number 2. Convert the pivoted equation into a matrix form Ax equal to b. So whatever equation that we have written that equation in the matrix form. Step number 3. Now the first step to solve this problem is make this value, this is a11 equal to 1. Now how to make this value equal to 1? If we divide this value by this value only, then we will get answer equal to 1. So always remember that this is your row 1, this is row 2, this is row 3. This is column 1, column 2 and column 3. So here we are going to perform row operations. So how to make this row element, this is a11, how to make this a11 equal to 1? Divide this a11 by a11 only. Now we have to divide throughout to this row, that is row number 1. So R1 equal to R1 divided by A11. So what you will get? This element A11 divided by A11 you will get 1. Now we have to perform this operation for total row. So therefore A12 divided by A11. So here I have written A12 divided by A11. Then A13 divided by A11 and B1 divided by A11. So this is what is the operation that we have performed only on row number 1. Now for the simplicity, here we can write, instead of writing now A12 divided by A11, I can write here A-12 so that it will be easy further. A13 divided by A11, I can write here A-13 and B1 divided by A11, I can write here B-1. Step number 4. Now convert the remaining element of a first column under 1 as a 0. That is, make A21 equal to 0 and A31 equal to 0 by taking help of A11. So let's understood what is the meaning of this step. This is what is the previous matrix that I have taken here. Now in this column, this is your column number 1. I want to make these two elements 0. Means I want to make A21 equal to 0 and A31 equal to 0. So for making A21 equal to 0, I have to take help of this element. This is your A11. To make A31 equal to 0, I have to take help of this element, which is again A11. So remember how to write a formula or how to write equation here. I want to make change in R2. So therefore R2 means what? This element, that is A21. This is your row 2. This is your row 3. So that's why here I have written R2. Now how to remember this? I want to make change in R2. So write R2 equal to R2. Now I have to take help of which element? A11. A11 means what? A11 means this. So in A11, this is what is your A11. So in this case, what is this? A11 is nothing but it is at R1. So therefore here I have written R1. Now R2 equal to R2, some space is provided here and I have written R1. Now what is the value of R2? Now here value of R2 is A21. So therefore as it is plus A21, so here you have to write minus A21. So what is the formula to make this element equal to 0? R2 equal to R2 minus A21 into R1. Similarly, I want to make this element, that is A31 equal to 0. So how to make it? So write R3. I need to make a change in R3. So R3 equal to R3. Again, I want to take help of which element? Yes, R1. I want to take help of R1. So therefore R1 I have taken here. Now what is this? This is plus A31. So here I have written minus A31. So what is the equation for this? R3 equal to R3 minus A31 into R1. So perform the operation on each and every column. This is very important. So by performing the operation, what you will get? These two elements will be 0. Now on this column, these two elements, I have written, instead of writing A22 and A32, I have written here A-22, A-32. Then instead of writing A23 and A33, I have written here A-23 and A-33 just for identification purpose. Instead of writing B2 and B3, I have written here B-2 and B-3. Step number 5. Now convert second diagonal element as 1. Now what we have to do? Our aim is to make this element equal to 1. So how to make this element 1? You have to divide whatever number which is present here by that number so that you will get answer as 1. So divide second row by A-2 to make it as a 1. So that's why R2 equal to R2 divided by A-2. So this is what is your matrix. So what happens here? When I divide by A-22 to this row, what happens? This element is 1. Then instead of writing A-23 divided by A-22, for a simplicity I have written A-23. So likewise I have written here B-2. Understood this concept? Next step. Step number 6 is, now convert remaining element of second column under 1 as 0. Now what we have to do here? This is what is our second column. Now I want to make this element 0. Remember that, suppose if I want to make these two elements 0 of column 1, I have to take help of this element. This is called as, I can say R1 or A11. Now if I want to make in a column 2, if I want to make this element as a 0, then I want to take help of which element? This is what is called as A22, or we can say that it is row 2. So therefore here make A-32 equal to 0 by taking help of R2. So again I need to make change at which element? A-32 means this is at row 3. So here I have written row 3 equal to row 3. Now I want to take help of which element? I want to take help of this element. This is your at position R2. So therefore I have written here R2. Now what is this value? A dash 32. It is positive, so just write minus A dash 32. So this is what is your equation, R3 equal to R3 minus A dash 32 into R2. Now perform this operation on row 3, so you will get this matrix. So what? This becomes 0. Now for a simplicity, I have written here, instead of writing A dash 33, I have written here A double dash 33 and B double dash 33. Okay. Next step, step number 7. Convert third diagonal element as a 1. That is, make A double dash 3 equal to 1. Now what I have to do? I want to make this diagonal element as a 1. So how to make this diagonal element 1? I want to divide this number by this number only, so that the answer will be equal to 1. So what is the formula for that? R3 equal to R3 divided by A double dash of 3, 3, 3. So you will get a matrix like this. So this element becomes 1. Instead of writing here B double dash of 3, here I have written B triple dash of 3 for simplicity. Step number 8. Now there are no future elements available under this diagonal element, that is for a third column. Hence we have to apply backward substitution for the solution. Now what I have to do? Now 0 into x plus 0 into y plus 1 into z equal to b triple dash of 3. So therefore directly I have written z equal to b triple dash of 3. So whatever will be the answer of z, that z is nothing but what? B triple dash 3, whatever value which is present here. Next is 0 into x plus 1 into y plus a double dash 2 3 into z equal to b double dash of 2. So I have written this equation. Now what you have to do? You have to find value of y. Now you know what is the value of z. What is the value of z? It is b triple dash of 3. So substitute here and find out y. So you will get b2 double dash 2. This term I am going to shift towards right hand side. So it will be minus a double dash 2 3 into b triple dash of 3. B triple dash of 3 is nothing but what? It is the value of z. So substitute the value of z here, you will get b triple dash of 3. And what is the next? 1 into x plus a dash 1 2 into y plus a dash 1 3 into z equal to b dash 1. So write this equation. I have written this equation. And again what to do? Again substitute value of y and z from previous equation in this equation, so that you will get x equal to. So I have written here x equal to b dash 1 is as it is. These two terms, when I shift towards right side, it will be a minus. So it becomes minus a dash 1 2 into, what is the value of y? Value of y is this. So I have substituted here. So this will be your value of y. Now minus a dash 1 3 into z. What is the z? Z is b triple dash of 3. So I have substituted here. So with the help of this method, you will get values of x, y and z. Remember important note, in this method you have to make upper triangular matrix and then make use of back substitution method to find the values of x, y and z. What is upper triangular matrix? It is a square matrix in which all the elements below the principal diagonal elements are 0. So if you observe here, this is what is your diagonal element. So all the elements below principal diagonal elements are 0. This is what is called as upper triangular matrix. So by making upper triangular matrix and then use of a back substitution method, we can find out values of x, y and z here. Let's discuss the problem of Gauss elimination method. The question is, solve the following set of linear simultaneous equation using Gauss elimination method. 3x plus y plus 2z equal to 8, 2x plus 3y plus z equal to 9, x plus 2y plus 3z equal to 6. So first step is, let us perform partial pivoting.
Now remember that always do a partial pivoting, means arrange the equations in the following manner having the highest value for all the diagonal elements. As the equations are already pivoted, means what to do? First check elements of the x or coefficients of the x. Whose coefficient of a x is greater, take that equation as equation number 1. So here this equation has a coefficient of x which has greater value, that is it is 3 value. So therefore this is a first equation. Now leave that equation, check these two equations. Now here check coefficient of a y. Now the 3 is larger compared to the 2, so therefore this is the second equation and remaining is the third equation. Now as the equations are already pivoted, so therefore we can take equation as it is: 3x plus y plus 2z equal to 8, 2x plus 3y plus z equal to 9, and x plus 2y plus 3z equal to 6. First step is convert the given equation into matrix form Ax equal to b. So we have written the given equations after pivoting in a matrix form. Now step number 2 is make A1 1 by 1. Now what to do? Whatever element which is present here, make that element 1. If there is a 1, then there is no problem. But if there is a value other than 1, then we have to make this element 1. Now if you observe here, the value is 3, means I have to divide this row. This is the first row, this is second row, this is third row, this is first column, this is second column, this is third column. So I want to divide row, this is the first row, by 3 so that this element will become a 1. So I want to make a change in which R1. I have to take a help of R1 only. So therefore what I have to write, R1 equal to R1 divided by 3. So this is what is your matrix. Now the second row and third row will remain as it is. Just you have to divide first row by 3. So this element becomes 1. This will be 1 by 3. This is 2 by 3, and last this element will be 8 by 3.
Now step number 3 is convert remaining elements of first column under 1 as 0. That is, make A21 equal to 0 and A31 equal to 0 by taking help of A11. Now what to do? With the help of this element, I want to make this element as a 0 and this element as a 0. So therefore, now I want to make change in which element? R2. So I have written here R2 equal to R2. For this column 1, I have to take help of this element. This is at row 1. So therefore I can write row 1. Now what is the value at row 2 here? This is your plus 2. So therefore you can write here minus 2. So what is the formula to make this element 0? R2 equal to R2 minus 2 into R1. Similarly, I want to make this element, that is this is a 1. I want to make this 1 as a 0 with the help of this element. So how to do? R3 equal to R3. I want to take help of R1. So therefore here I have written R1. Now what is the element here? It is plus 1. So therefore it will be minus 1. So how to write equation? Equation is to make this element equal to 0, R3 equal to R3 minus R1. So this is what is a matrix. Final answer. Now how to solve this? These two elements become 0. It's okay. I want to perform this operation on each and every column. Remember, I want to perform this operation on each and every column. So this becomes 0. It's okay. Now when I talked about this element, so how to do? What is your R2? R2 is 3 minus 2 into R1 means what? Minus 2 into 1 by 3. So R2 equal to 3 minus 2 into 1 by 3. What is the answer? Answer will be 7 by 3. Next, for this column, R2 is 1 minus 2 into R1 is 2 by 3. So if you substitute this value 1 minus 2 into 2 by 3, you will get answer as minus 1 by 3. Again, for this column, R2 is 9 and R1 is 8 by 3. So substitute 9 minus 2 into 8 by 3. So you will get answer here as 11 by 3. Same you have to perform for this operation, R3 equal to R3 minus R1. So 1 minus 1, it becomes 0. For this column, R3 is 2, R1 is 1 by 3. So 2 minus 1 by 3, you will get answer as 5 by 3. Then for this column, now what is R3? It is 3. What is R1? It is 2 by 3. So 3 minus 2 by 3, you will get answer as 7 by 3. For this column, what is R3? R3 is 6. R1 is 8 by 3. So 6 minus 8 by 3, you will get answer as 10 by 3. Let's discuss next step. Step number 4. Convert second diagonal element as a 1. That is, make A22 equal to 1. Now, this is what is your previous matrix. Now, what to do here? Now, I want to make this element as a 1. So, this is your R2. So, how to make this element as a 1? Either you divide this value by the same value or multiply by reverse of the value. Means what? If you divide 7 by 3 by 7 by 3, answer is 1. Or if you multiply 7 by 3 by 3 by 7, then you will get answer as a 1. So I want to make change in which row? R2. So R2 equal to R2 divided by 7 by 3. So this is what is your solution. I want to make change only in R2. So R1 and R3 have to write as it is. R1 and R3 have to write as it is. So 7 by 3 divided by 7 by 3, it will be 1. For this column, what is R2? Minus 1 by 3 divided by 7 by 3. So what you will get? Answer as minus 1 by 7. For this column, what is your R2? R2 is 11 by 3 divided by 7 by 3. So you will get answer as 11 by 7. Now our next aim is to make this element, remember, make this element as a 0. So step number 5 is convert remaining element of second column under 1 as a 0. Now if you observe carefully here, under 1 value there is only one element. Means what? This is your R3. So if I want to make this element as a 0, I want to take help of this. This is very important. Remember, suppose if I want to make these two elements 0 of a column 1, then you have to take help of R1. That is, this is a diagonal element. Now, if I want to make in this particular column, if I want to make this element as a 0, then you have to take help of this element which is called as R2. Again, this is a diagonal element. And so, let's perform the operation. How to do it? I want to make change in which row? R3 equal to R3. Now, in order to make this element 0, I want to take help of this element which is present at R2. Okay. Now, what is the value here? It is plus 5 by 3. So, therefore, you have to write here minus 5 by 3. So, what is the formula? Formula is R3 equal to R3 minus 5 by 3 into R2. So, let's solve this. You will get a matrix. Now, I want to make change only in R3. So, R1 elements, R2 elements, write as it is. There will not be any change. Now, this becomes 0. It's okay. For this column, what is R3? R3 is 7 by 3. What is R2? Minus 1 by 7. So substitute here 7 by 3 minus 5 by 3 into minus 1 by 7. So what you will get? You will get answer it as a which element? Yes, you will get answer it as a 18 by 7. Next is for this column, what is your R3? Yes, R3 is 10 by 3. What is your R2? R2 is 11 by 7. So substitute values, you will get answer as a 5 by 7. Next step is convert third diagonal element as a 1. That is, make A33 equal to 1. Now what I want to do, this is what is the previous matrix that I have copied here, I have taken here. I want to make this element as a 1. So how to make this element as a 1? Either you divide 18 by 7 by 18 by 7, or you multiply 18 by 7 by 7 by 18. So I want to make change in which row? Yes, R3. So therefore here I have written R3 equal to R3 into 7 by 18. Okay. So therefore what happens here? R1 and R2 elements keep as it is. So I have written as it is. So when I multiply 18 by 7 by 7 by 18, this will be 1. Next is for this column, what is R3? It is 5 by 7. So substitute 5 by 7 into 7 by 18. So you will get answer here as a 5 by 18. Understood the concept? Now the last is, there are no future elements available under this diagonal element. That is for third column. Hence, we have to apply backward substitution for the solution. Now what do you mean by backward substitution? Here if you observe, I can write equation as 0 into x plus 0 into y plus 1 into z equal to 5 by 18. So therefore, now as 0 into x, 0 into y, nothing will be there. So directly I can write z equal to what? 5 by 18. So 5 by 18 means 0.2777. Next, 0 into x plus 1 into y minus 1 by 7 into z equal to what? 11 by 7. So this is what is your next equation. Now what you have to do? Just you have to substitute value of z here. What is the value of z? 5 by 18. So substitute here 5 by 18. So this is your 11 by 7. If you transfer this term towards right side, you will get value for y. So y will be equal to 29 by 18 equal to 1.6111. And what is the last equation? 1 into x plus 1 by 3 into y plus 2 by 3 into z equal to 8 by 3. So write this equation, and again what to do? Whatever values that you got of y and z, substitute here values of y and z and transfer these both terms towards right hand side. So you can get value of x as 35 by 18 equal to 1.9444. So finally you can write it as x equal to 1.944, y equal to 1.611 and z equal to 0.2777.